Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on stoichiometric conversions. Stoichiometric conversions are very similar to the molar conversions that we've done in the past, but we're just adding a few steps to that process. So for stoichiometric conversions, we are converting from either particles, grams, or liters of one substance to particles, grams, or liters of a different substance. So to change substances, we need to be in moles. So we first use the molar conversion to take my given particles, grams, or liters and put them into moles. Once I'm into moles of what I'm given, I can use the mole ratio to get into the moles of what I'm trying to find. Once I'm in moles of what I'm trying to find, I can use one of these three conversions again to then go from moles to particles, moles to grams, or moles to liters. All right, so most of these are going to be three-step problems. We do need to pay attention to what units we're starting with. If we're already starting with moles, then there's no reason for me to convert to moles, and so I don't need a molar conversion at the front of my problem. If I'm finding moles, then I don't need to convert out of moles, and so I don't need to do any molar conversions at the end of my problem. So we need to pay attention to the units that we have so that we can make sure that we are solving for the correct thing. So first we have here this equation. You need to balance it. So this is a chew problem. A quick shortcut to chew problems is if I am trying to balance this, I can look at my hydrogens. If I divide my hydrogens by 2 and I get an odd number, it means that I'm going to get an odd number of oxygens at the end. So I'm just going to go ahead and put a 2 here to prevent that from happening. So 2 times 2 is 4 carbons here. 2 times 2 is 4 hydrogens, 2 hydrogens here, so I put a 2 here. 4 times 2 is 8 oxygens. 2 times 1 is 2 oxygens. 8 plus 2 gives me 10. So I put a 5 here. Okay, so now let's take a look at the problem itself. How many grams of CO2 can be made from reacting 2.39 grams of O2? All right, so I always start with the information I'm given and the information I'm trying to find because that's going to help me set up my problem. So I have 2.39 grams of O2, and I'm trying to find grams of CO2. All right. So I'm going to go grams of O2 to moles of O2, and then moles of O2 to moles of CO2, and then moles of CO2 to grams of CO2. All right, so to go from grams of O2 to moles of O2, I'm going to need a molar conversion. Moles to grams means that I am looking at molar mass. So if I'm looking for molar mass, I know 1 mole is equal to the molar mass of O2. Oxygen is 16. 16 times 2 is 32. So this will be 32 grams of O2. All right, and then to get from moles of O2 to moles of CO2, I use a mole ratio, which I will do from my balanced equation here. And then from moles of CO2 to grams of CO2, I'm going to need another molar conversion. All right, so since I'm going moles to grams, again, I'm going to need molar mass, but this time I need the molar mass of CO2, which is going to be 44.01 grams CO2. If you need a refresher on how to find molar mass, you should watch the molar mass tutorial video. All right, so now I have everything that I need, so I'm going to set up my problem. 2.39 grams of O2 times, since I'm starting with grams of O2 will go in the denominator to cancel. So I have 32 grams of O2 is equal to 1 mole of O2. All right, so now that I'm in moles of O2, I can go to moles of CO2 using my mole ratio. So I come up to my problem here and I see that O has a coefficient of 5, so that means that I have 5 moles of O2. O2 goes on the bottom so that they will cancel out. What I'm trying to find is moles of CO2. So the coefficient in front of the CO2 is 4, so I put a 4 there. So now that I'm in moles of CO2, I can then do my final step and convert to grams by using the molar mass of CO2. So 1 mole CO2 is 44.01 grams of CO2. Grams of O2 cancel with grams of O2, moles O2 cancel with moles O2, moles CO2 cancels with moles CO2, and I'm left with grams of CO2. So this is going to be 2.39 times 4 times 44.01 over 32 times 5. So you'll notice that I put everything here in parentheses. If you don't put it in parentheses in your calculator, then you will not get the correct answer. So you have to do parentheses for everything on top and then parentheses for everything on the bottom. So when we do this math, we get 2.629597 grams of CO2. All right, so let's check our sig figs. I have 3 sig figs in my problem. So 3 sig figs would be 2.63 grams of CO2. All right, let's do some more. How many liters of O2 are required for the formation of 16.85 grams of H2O at STP? All right, so I'm given here 16.85 grams of H2O, and I am looking to find liters of O2. So here I go, grams H2O to moles H2O, and from there, moles of O2, and from there, liters of O2. All right, so to go from grams to moles, I'm going to need the molar mass conversion. So 1 mole is 18.02 grams of H2O. And for my moles to liter conversion, I will need 1 mole is equal to 22.4 liters, which is okay because my problem says that I'm at STP. It's 22.4 liters. All right, so let's set up our problem. I have 16.85 grams of H2O. So that means that grams of H2O will go in the denominator. So 18.02 grams H2O is equal to 1 mole of H2O. So now I can do my mole ratio to go from moles H2O to moles O2. So my problem says I have 2 moles of H2O, and I'm converting into moles of O2. So my reaction says I have 5 moles of O2. All right, and then lastly, I go from moles of O2 to liters of O2, which means that I need my 22.4 liter conversion. So moles of O2 are on top, so 1 mole O2 goes on the bottom, and 22.4 liters of O2 go on top. Grams of H2O cancel with grams, moles H2O cancel with moles H2O, moles O2 cancel with moles O2, and I am left here with liters. So parentheses 16.85 times 5 times 22.4 divided by parentheses 18.02 times 2. And when we do all that math, we get 52.364 liters of O2. So we check significant figures. It's 4 sig figs here. So 1, 2, 3, 4 would be 52.36 liters of O2. All right. So let's do another. So here we are given 7.2 liters of C2H2, and I'm trying to find molecules of H2O. So we can abbreviate molecules as MC. All right. So to get from liters of C2H2 to moles, I need my conversion factor. 1 mole is 22 liters. And I'm at STP, so I can do that. 2.4 liters of C2H2. And molecules of H2O is particles. So I need 1 mole is equal to 6.02 times 10 to the 23rd molecules of H2O. You can write RP instead of MC if you'd like to. All right, so I have 7.2 liters of C2H2. So I'm starting with liters, so liters go on the bottom. 22.4 liters, C2H2 is 1 mole, C2H2. And now I convert from moles of C2H2 to moles of H2O using my mole ratio. So in my problem, I have 2 moles of C2H2. That goes on the bottom, so they'll cancel. And H2O I have 2 of as well. So I have 2 moles H2O. All right, and then lastly, I need to convert moles of H2O into molecules. So I'll get rid of H2O by putting 1 mole H2O on the bottom and 6.02 times 10 to the 23rd molecules H2O on top. Liters cancel with liters, moles C2H2 cancel moles C2H2, moles H2O cancel moles H2O, and I'm left with molecules of H2O. So 7.2, parentheses, 7.2 times 2 times 6.02 times 10 to the 23rd divided by parentheses, 22.4 times 2. Close parentheses. And I get 1.935 times 10 to the 23rd molecules of H2O. For my significant figures, this has 2 sig figs, though my answer will also only have 2 significant figures. 1.9 times 10 to the 23rd molecules H2O. So I check my significant figures. So now I check my significant figures. I get 2 significant figures from my problem. So my answer has 2 significant figures, 1.9 times 10 to the 23rd molecules of H2O. All right. So next up, we are given here 2.14 times 10 to the 24 molecules CO2, and I'm trying to find grams of C2H2. All right, so first I need to go from molecules to moles, so I'm going to need a conversion factor. Molecules are the same as particles, so 1 mole is 6.02 times 10 to the 23rd molecules of CO2. And then I'll do mole ratio, and then I'll need to do moles of C2H2 to grams. So my gram conversion is molar mass. So 1 mole of C2H2 is equal to 26.04 grams of C2H2. All right, so I start with what I'm given, 2.14 times 10 to the 24 molecules of CO2. So to cancel molecules, I put them on the bottom. 6.02 times 1023 molecules CO2 is 1 mole CO2. All right, and then I do my mole ratio for CO2. I have 4, so I do 4 mole CO2 on the bottom. I'm trying to find C2H2, it's a 2, so 2 moles C2H2 on top. And then lastly, I need to convert from moles to grams. So 1 mole on the bottom and 26.04 grams C2H2 on top. You'll notice for all of these that all the information that's given goes on the bottom. All the given information is divided across the bottom, and all the information we're trying to find is multiplied across the top. It's the same every single time. 1 mole goes on the top, and then whatever we're converting from goes on the bottom. Mole ratio, 1 mole on the bottom, and whatever we're converting to goes on top. All right, so it's the same sort of general formula every single time, as long as we are starting with particles, grams, or liters, and ending with particles, grams, or liters. Okay, so molecules CO2 cancel with molecules, moles CO2 cancel with moles, moles C2H2 cancel with moles C2H2, and I'm left here with grams of C2H2. So parentheses 2.14 times 10 to the 24th times 2 times 26.04 over parentheses 6.02 times 10 to the 23rd times 4, close parentheses. You don't have to put the scientific notation into an extra set of parentheses here. You can if you want to, but as long as you have the whole numerator in one set of parentheses and the whole denominator in one set of parentheses, that's really all that you need. All right, so when we do this math, we get 46.2837 grams of C2H2. So for significant figures, 3 sig figs here, 1, 2, 3. That 8 means the 2 rounds to a 3. So 46.3 grams of C2H2. All right, so every single one of these problems has 4 parts that I have to get correct. I have to have the correct numerical answer, I have to have the correct significant figures, I have to have the correct unit, and I have to have the correct substance. All right, so we have to have all 4 of those things in place in order to get my answer fully correct. All right, so here we have a brand new equation, so we'll need to balance this first. I don't want to start with the h's because I have h here and h here, but I only have h in one place over here, so I'm going to ignore that for right now. Let's look at the SO4. We have 3 over here, so I'll do 3 here. And then the Al, I have 2 here, so I'll do 2 here. And then let's take a look at oxygen. So I have 3 oxygen times 2 is 6, so I'll put a 6 here for the oxygen. And then I have 6 H's here and 6 H's here, so 6 plus 6 is 12, and 6 times 2 is 12, so that's balanced, so I can just put a 1 here. All right, so we're given here 45 liters of H2SO4, and we are asked to find particles of Al2SO43. So particles are the same as RPs, so Al2SO43. All right, so to get from liters to moles, I'll need the conversion. 1 mole is equal to 22.4 liters of H2SO4. And then to get from moles to RPs of Al2SO43, I'll need that conversion. So 1 mole is equal to 6.02 times 10 to the 23rd RPs Al2SO4. 3. All right, so if we set up our problem, we start with what we're given, 45 liters of H2SO4. So since I'm starting with liters, liters will need to go in the denominator. So 22.4 liters of H2SO4 is equal to 1 mole H2SO4. All right, now that I'm in moles of H2SO4, I can convert into moles of Al2SO43. So I'll need to look at my equation. So I have 3 moles of H2SO4. So H2SO4 goes on the bottom so that these can cancel. And then I want to get it into Al2SO43. So I have 1 of those. So I'll do 1 mole Al2SO43. And then lastly, I'll need to go from moles of Al2SO43 to RPs. So since I have moles on top, I'll put 1 mole Al2SO43 on the bottom, and 6.02 times 10 to the 23rd RPs Al2SO43 on top. All right, and then I will do parentheses 45 times 6.02 times 10 to the 23rd over parentheses 22.4 times 3. Right? So when I do this math, I get 4.03 times 10 to the 23rd RPs. And now I'll put this into significant figures. This is 2 sig figs, and so 4.0 will also be two significant figures. All right, just as a refresher on significant figures, if there's a decimal point, all zeros at the end of a value are significant. So since there's a decimal point here, this 0 is significant, and so that's why this is two sig figs. Okay, let's look at another. So here we are given 7.29 times 10 to the 22nd formula units of AlOH3. And we are asked to find grams of H2SO4. Right? It's the same equation from before. We balanced it once, so we don't need to continue balancing it. So it's got that there. So let's take a look at what conversions we need. Since we're starting with formula units, we'll need the formula unit conversion. Formula units are just particles. So 1 mole is 6.02 times 10 to the 23rd formula units of AlOH3. And then I'm finding grams, so my gram conversion is 1 mole is equal to the molar mass, and the molar mass of H2SO4 is 98.08 grams. So we'll start with what we're given, 7.29 times 10 to the 22nd formula units AlOH3. And since we're starting with formula units, we'll put formula units in the denominator. So 6.02 times 10 to the 23rd formula units AlOH3, which means we put 1 mole AlOH3 on top. And then I need to convert from moles of AlOH3 to moles of H2SO4, so I need my mole ratio. AlOH3 is on top, so AlOH3 will go on the bottom. And in my equation, I have 2 moles of AlOH3. And then on top, I have 3 moles of H2SO4. And now I'm in moles of H2SO4, so my last step is to convert from moles of H2SO4 into grams by multiplying by the molar mass. So, parentheses 7.29 times 10 to the 22nd times 3 times 98.08. Close parentheses over 6.02 times 10 to the 23rd times 2 close parentheses. All right, and when we do all of that math, and we get 17.815 grams H2SO4. So we check our significant figures. 7.29 is 3 sig figs. When looking at significant figures, the times 10 doesn't matter. It doesn't count towards my significant figures at all. It's just whatever the value of the number is. All right, so 3 significant figures, so 1, 2, 3. So this will be 17.8 grams of H2SO4. All right, next up, we have how many liters of H2O are created when 3.78 grams of Al2SO43 are produced at STP. All right, so here we're given 3.78 grams Al2SO43, and we're trying to find liters of H2O. All right, so to get from grams to moles for my first one, I need the molar mass conversion. The molar mass of Al2SO43 is 342.14 grams. And then I'll need a liter conversion, 22.4 liters at STP, and I am at STP, so that is not a problem. So this is 22.4 liters of H2O. All right, so we start with what we're given. 3.78 grams Al2SO43 times, starting with grams, so grams will go in the denominator, so I put my molar mass down here, 342.14 grams of Al2SO43, and on top I put 1 mole Al2SO43. Right? Now I need to convert from moles of Al2SO43 to moles of what I am trying to find, which is H2O. So I look at my equation. There's no coefficient in front of the Al2SO43, so that means it's just a 1. So this is going to go on the bottom so that moles of Al2SO43 will cancel with moles of Al2SO43. And then I'm trying to get to H2O. So I have a 6 in my equation, so that means I have 6 moles of H2O. So now I go from moles of H2O to liters, so moles will cancel if I put 1 mole of H2O on the bottom, which means that I put 22.4 liters of H2O on top. Grams cancel with grams, moles cancel with moles, moles cancel with moles, and I'm left with liters of H2O. All right, so 3.78 times 6 times 22.4 divided by parentheses 342.14 times 1 times 1, so that's just 342.14 on the bottom. All right, and so we'll put this into the calculator, and when we do this math, we get 1.4848 liters of H2O. We check our sig figs. 3.78 is 3 sig figs. 1, 2, 3. So my answer will be 1.48 liters of H2O. Last one. How many grams of AlOH3 would it take to make 15.60 grams of H2O? All right, so here we are given 15.60 grams H2O, and we're trying to find grams of AlOH3. All right, so I need to get to grams of H2O, so I need my molar mass conversion. 1 mole is equal to 18.02 grams of H2O. And then to get from moles of AlOH3 to grams, I again am going to need my gram conversion. So this time I need the molar mass of AlOH3, which is going to be 78.01 grams of AlOH3. All right, so now let's set up our problem. We start with what we're given, 15.60 grams of H2O. So grams of H2O cancel with grams, so grams goes on the bottom. 18.02 grams H2O, which is molar mass on the bottom, and 1 mole H2O on top. Now I do mole ratio. H2O goes on the bottom to cancel. So my coefficient for H2O is 6, so I have 6 moles of H2O. And then I'm converting to AlOH3, so my coefficient here is 2, so it'll be 2 moles of AlOH3. All right, and then lastly, I need to go from moles to grams, so I use molar mass again. 1 mole goes on the bottom so that they'll cancel. And the molar mass, 78.01 grams AlOH3, goes on top. Grams H2O cancel with grams, moles H2O cancel with moles AlOH3 cancel with moles AlOH3, and I'm left with grams of AlOH3. So 15.60 times 2 times 78.01 divided by 18.02 times 6, all that in parentheses, and I get 22.511 grams of AlOH3. Check my significant figures. All right, so here I have 1, 2, 3, and then because the 0 is at the end and there's a decimal place, this is 4 sig figs. So 1, 2, 3, 4 would be 22.51 grams of AlOH3. Hooray and huzzah. All right, so that is stoichiometric conversions. This has been another episode of Chemistry with Wikipedia Tutorial Edition. I hope you learned something, and until next time, keep on chemin'.